The instruments read normal, no collision alarm, no heat warning, no vibration through the hull. The cockpit is perfectly quiet, and outside the forward window there is nothing visible, just the dark, the way there always is. Then you glance at the differential gravity sensor. Your feet are registering a pull that is fractionally stronger than your head. The gap is small. It is growing. A neutron star doesn't need to touch you. The gap between your head and feet is enough. You are still thousands of kilometers away. At this distance, on any other approach to any other object in the known universe, that differential would be noise, a rounding error, a sensor artifact. But this is not any other object, and the sensor is not wrong. The number is still small. That is the only reason you are still intact. To understand what is already happening to your body, you need to understand what gravity actually is at this scale. Gravity is not a uniform push or pull. It is a field, a slope. And every point along your body sits at a slightly different position on that slope. Your feet are closer to the source. Your head is farther. That difference in position means the pull on your feet is measurably stronger than the pull on your head right now. That difference in pull is a force. It is pointing outward from your center. It is trying to stretch you. On Earth, this happens too. The moon pulls your feet slightly harder than your head. The difference is so small that it produces tides in the ocean, but nothing your body can detect. That is what tidal force is, the gravitational difference between 2 points separated by a distance inside a gravitational field. Near a neutron star, the ocean evaporates. A neutron star contains more mass than the sun, more than 1 million Earths compressed together, packed into a sphere roughly 20 kilometers across. That is approximately the width of a city. The surface gravity on that sphere is not strong by comparison to Earth's. It is 200 billion times stronger. The gravitational slope that object generates does not stay near the surface. It reaches outward through space as a steep gradient, and the steepness does not fall off gently. The tidal force, the difference in pull between 2 points in your body, grows as the cube of your distance from the center, not linearly, as a cube. That means closing half the distance does not double the danger. It multiplies it by 8. The last 1,000 kilometers of approach are not merely the most dangerous. They are incomprehensibly more dangerous than anything that came before them. You entered that zone before the sensor first registered the gap. The human body is held together by molecular bonds. Every tissue, every organ, every millimeter of skin is a collection of molecules that prefer to stay attached to their neighbors. Those preferences have limits. They will release under sufficient force, and the force currently growing between your head and your feet is not asking your molecular bonds for permission. It is pulling every atom in your body in a slightly different direction simultaneously. Not your body as a whole object. Every component of your body, independently, at every scale. The skin on your feet is being pulled toward the star at a different rate than the muscle beneath it. The muscle is being pulled at a different rate than the bone inside it. Each layer is separating from the layer adjacent to it, slowly at first, then faster as the distance closes. This is spaghettification, not a metaphor, not a film effect. The actual physical process by which an extended object is elongated and torn apart along its length by differential gravitational force. It begins at the outermost points, your hands, your feet, and progresses inward toward your core as the gradient steepens. The word sounds almost gentle. The physics is not. Think of wringing out a wet cloth. You are not hitting the cloth. You are pulling each layer in a slightly different direction until the fibers separate along their weakest connections. The cloth does not explode. It simply comes apart, fiber by fiber, layer by layer, while looking, from a distance, like it is still intact. That is what is happening inside your body right now, from the outside, in silence, with no alarm and no visible damage, while the sensor reads a number that is still growing. Your ship is experiencing the same process. The hull is not a biological structure, but it is an extended object with mass distributed along its length. The nose of the ship is at a slightly different distance from the neutron star than the engines. The tidal force pulling them apart is the same force pulling your head from your feet. Steel and titanium and every composite material humanity has ever engineered have molecular bonds the same as your tissue does. Those bonds have limits too. The tidal stress is not compressing the hull from outside, where the material's rated strength could resist it. It is inserting itself between every pair of adjacent atoms and pulling them in different directions. The material's tensile strength is irrelevant when the force bypasses the material and addresses the bonds directly. No structure survives what addresses it at the atomic level. The first symptom the ship registers is not a hull breach. It is the misalignment of precision components, navigation gyroscopes, thruster alignment brackets, the seals along the viewports that are rated to fractions of a millimeter and are now being pulled out of tolerance by a force that acts differently on the forward mount than the aft one. Systems begin failing not because something struck them, but because the physical geometry they were built to maintain is no longer the geometry the universe is allowing. An instrument designed to measure distance to within a meter begins producing nonsense because the instrument itself is no longer the same length it was when it was calibrated. The ship is becoming unreliable faster than you can diagnose it. In February 1979, NASA's Einstein Observatory, the first imaging X-ray telescope placed in orbit, detected an extraordinary event from a neutron star designated MXB 1730-335, known to astronomers as the Rapid Burster. In the space of seconds, the object released energy equivalent to weeks of continuous solar output. The X-ray burst was catastrophic in its intensity and speed. What the Einstein Observatory recorded was not an explosion in the conventional sense. It was the signature of matter falling into the neutron star's gravitational field and releasing its energy with an efficiency that no conventional heat source can approach. The burst was the first direct observational confirmation that the region surrounding a neutron star is not simply dangerous by proximity, it is an active demolition environment where infalling material is converted into energy at a rate that no shielding model developed up to that point could account for. The theoretical safe approach distances that astrophysicists had been working with prior to 1979 were revised immediately. The revision went in one direction only. The rapid burster did not require a spacecraft to approach it. It demonstrated that the neutron star's gravitational environment behaves as a mechanism, converting proximity into energy release without requiring contact, without requiring a target, simply by existing and allowing matter to fall toward it. Distance was already not the protection it appeared to be. The obvious solution arrives at this point in almost every discussion. Build a stronger ship, use better materials, engineer the hull to resist the differential stress. If the tidal force is pulling the structure apart, build a structure that holds together under greater tension. It is a reasonable engineering instinct. It is the same instinct that produced every pressurized vessel, every deep-sea submersible, every re-entry vehicle humanity has ever put into service. The neutron star does not care about tensile ratings. The reason material strength fails here is not a limitation of current engineering. It is a limitation of what force is allowed to act on. Every material that has ever been engineered derives its strength from the bonds between its atoms. Stronger materials have stronger bonds. Carbon fiber, tungsten, neutron-absorbing alloys. All of them are strong because the atoms in their lattice resist being separated from their neighbors. The tidal force does not try to pull the material apart as a unit. It reaches into the lattice and pulls each atom in a slightly different direction based on that atom's individual position in the gravitational field. The bond between two adjacent atoms is not being stretched by an external load applied to the bulk material. It is being stretched by the difference in the gravitational pull on those two atoms specifically. And the bond strength was calibrated by nature for a universe in which gravitational gradients at this scale do not exist near things astronauts approach. It was not calibrated for a neutron star. A hull rated to withstand 10,000 times Earth atmospheric pressure fails at this task for the same reason a spiderweb fails to hold a lake. The force is not resisted by tensile strength because tensile strength is the strength of bonds. Tidal force is the thing that attacks bonds. Thicker walls mean more atoms being pulled in more slightly different directions. The stronger you build, the more total bond stress the structure accumulates. At sufficient gradient, more material means more failure surface area, not more resistance. The ship that should protect you becomes the mechanism by which more of your atoms are exposed to differential pull. You cannot armor against something that works from the inside. The fallback response in the cockpit is to fire the engines and leave. Accelerate away, reverse thrust, create enough velocity to escape the gradient before the threshold is crossed. This is the instinct that every pilot in every emergency follows. Apply power, move, create distance. The physics of this situation produces an outcome that reverses the instinct's logic entirely. Firing the engines generates acceleration. Acceleration is a force. That force acts on the ship's mass, which is now a mass being pulled differentially across its length by the tidal gradient. Adding acceleration to a structure already under tidal stress does not cancel the tidal stress. It adds to the net differential force acting on every component. The engine thrust that was supposed to pull you free is adding its load to the load that was already separating the atoms in your hull and your tissue. You are trying to outrun the gradient by creating more force in the same system that the gradient is already disassembling. Moving faster tears you apart faster. The only geometry that escapes this is instantaneous retreat. Distance opened so quickly that the cube scaling of the tidal force has no time to compound. No propulsion system built by humanity produces that. The fastest spacecraft ever launched, Voyager 1, moves at roughly 17 kilometers per second relative to the Sun. A meaningful retreat from a neutron star's lethal tidal zone requires covering hundreds to thousands of kilometers in the time the gradient is already growing. At 17 kilometers per second, you are covering the distance. The gradient is covering it faster. By the time the engines reach full thrust, the number on the differential sensor has already moved past the threshold for joint separation at the extremities. Your hands detach from the force acting on them before the engine confirms ignition. The biology of this does not produce impact trauma. There is no single blow. There is no moment of collision. The process is a progressive uncoupling, the loosening of every attachment point in the body's structure, from the outermost layers inward, in the sequence that the molecular bonds dictate. Tendons go before bone, skin releases before the muscle beneath it. The circulatory system, which is itself an extended structure running the full length of the body, experiences differential pull along its entire length simultaneously, and blood does not stay contained in vessels that are no longer shaped correctly. The order of events is determined not by drama, but by bond strength. Whatever holds together least strongly in your body's molecular hierarchy separates first. The process is quiet. It is systematic. It looks, from the outside, like nothing at all, until it is complete. No alarm in the ship was designed to detect this. There is no proximity warning for a gradient. The alarm systems were built for collision, for pressure loss, for fire. They will read normal until the geometry of the vehicle is too distorted for the sensors to function. By then, the sensor data is no longer the most urgent problem. A neutron star generates a tidal field because it packs the mass of a star into the volume of a city, and every kilogram of that mass is pulling on every kilogram of everything around it with the same relentless precision. Black holes operate on the same principle, at larger scale and greater extremity. Gravitational wave detectors on Earth, instruments designed to measure ripples in spacetime itself, are sensitive enough to detect the tidal distortion produced by two merging neutron stars more than 1 billion light-years away. The geometry of space itself bends around these objects. Light curves around the surface of a neutron star so dramatically that you can see more than half its surface at once from any angle. The star shows you its own back. A single teaspoon of its interior material would weigh 10 million tons on Earth's surface. That density is not a number. It is the condition that produces everything else in this script. The gradient, the spaghettification, the molecular bond failure, the useless engines, the silent disassembly, all of it follows from that single physical fact. Mass this extreme, compressed this small, creates a slope in the gravitational field so steep that no extended object of human scale can cross it intact. NASA's planned crewed missions to lunar orbit and Mars account for radiation, microgravity bone loss, and psychological isolation. They do not account for tidal forces, because at those distances, tidal forces are irrelevant. But the generation of mission planners now designing theoretical frameworks for interstellar probes, programs like Breakthrough Starshot, concepts for laser-propelled craft intended to reach the nearest stellar systems in decades rather than millennia, will eventually work through the question of what a probe's approach geometry looks like near a compact stellar remnant. Several of the nearest candidate stars are neutron stars. The approach parameters will not be written by propulsion engineers. They will be written by the tidal radius. The question physics leaves on the table is this: how close is the closest approach that preserves structural integrity for any instrument we could build, and whether any science worth doing exists on the safe side of that line? The answer depends entirely on what you are willing to send, and whether whatever you send is still one object when it arrives.